Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss how to determine the coefficient of viscosity by orifice type viscometer. In our previous video lectures, we have already discussed various types of methods to calculate the coefficient of viscosity. So this is another one method by which we also can identify the value of viscosity. So we know that all the liquids have a natural resistance to flow, and that is known as the viscosity, and that is already inbuilt in the liquid itself is having. So that is called a natural resistance. So when the liquid is supposed to flow, and due to its viscosity, and it will move very fast or it will move very slow, so based on the viscosity. So now in this method, actually, if you see, here we have taken an experimental setup. So this is the setup of this experimental, and in this setup, if you see, this is the outer part of that, which is known as a constant temperature bath. So this constant temperature bath is taken to maintain the temperature of the liquid whose viscosity need to be measured. And this is the container. In this container, the liquid is present whose viscosity need to be measured. Okay, you can consider any kind of liquid here. You can consider water, you can consider oil, you can consider petrol, diesel, or you can consider some nanofluids. You can consider any kind of fluids. Okay, so whose viscosity you want to measure. So basically, we are going to determine the coefficient of viscosity. So this is mu, and while talking about this constant temperature bath, okay, here in the constant temperature bath, again we need to keep some liquid or some fluid, okay, and to maintain the temperature of the liquid whose viscosity need to be measured, as I told, because we know that the viscosity is directly proportional to temperature. If the temperature varies, the viscosity of the liquid is going to be varied. So we need to fix a temperature. Suppose we want to measure the viscosity of this liquid at a 20-degree temperature, then we need to maintain the constant bath temperature at 20 degree or a little bit more like 25, so that there will be a plus minus variation will be there, or 22 degree if you maintain the temperature of that. So here it will be maintained as a 20 degree maybe. And so similarly, at 20-degree temperature, if you want to measure viscosity, this constant temperature bath temperature need to be maintained 20 plus 22 something will be there. Then we can get the temperature at this 20 degree. Similarly, so this constant temperature bath will be maintain a fixed temperature. It won't vary with respect to time. So if you want to maintain the temperature of 60 degrees centigrade, so you just make the temperature of this constant temperature bath of 60 degree. Similarly, we can get the temperature of this viscosity, this liquid, near about 55 to 60 in between that, and we can measure the temperature. So that at that point, the temperature will be fixed. Okay, there is no variation of temperature. That's why the constant temperature bath kept here for measuring the viscosity of the liquid. So how in this orifice type viscometer, how it is actually measuring? So as I told, there is a capillary tube is there. So through this capillary tube, the liquid is to it flows to downwards. So liquid which is present here, actually it is to be closed, and when you open this part, so the liquid which is present here in this chamber, that will be come down, and at the bottom we have a measuring cylinder. At this measuring cylinder, we can measure what is the quantity of liquid is coming out from this chamber, so that with respect to time we can measure this. Okay, so this is all about the viscosity measurement actually. So this is one type of viscometer, as I told. I'll tell you which kind of viscometer this is. This viscometer, actually it is of several types are there. So one is reduced viscometer. One is known as reduced viscometer, and next we can say Seevolt viscometer is there. This reduced viscometer, or we used to call it as a angular viscometer. Okay, redwood or Anglo. So this mostly these are the viscosity viscometers are used to measure the viscosity. And here the principles of this viscometers are same, only their uses are in different areas. So this redwood viscometer mostly used at UK countries, and Seybold viscometers are used at USA. Okay, it's having their own reasons. Okay, for that they used to use in UK. Mostly they used to prefer this redwood viscometer, and USA they used to prefer this Seybold viscometer. But the principles are remains same. There is no change in principles. Okay, so because the concept of this measurement of this viscosity remains same, there is no changes on that. So okay, so here like in a different type of viscometer nowadays also came to the market for measuring the viscosity, and we can say what the principle of that. As I told, that constant temperature bath is there and the chamber is there, and from that liquid will be come out from this position, and that will be measured at the measuring cylinder. So this viscometer is actually known as Seybold viscometer. Okay, this is the type of Seybold viscometer. And here actually, as I told you, the measuring cylinder is there. In this measuring cylinder, the quantity of fluid or liquid which is coming out, that need to be measured with respect to some time period. Okay, so you can say there is a scaling part will be there in this measuring cylinder, and so that we can measure that what is the volume of fluid came to the measuring cylinder. Suppose time taken, two methods we can follow for measuring this one. One is, suppose you fix a time of 1 minute, and in this 1 minute time period, what is the volume of liquid stored in this measuring cylinder. So that one we can calculate what is the discharge came out, or what is the volume of liquid came out from there. We can also identify from here. Okay, or else you take a suppose we need to identify 60 cubic centimeter of liquid need to be collected at what time period. So here time period is the time period need to be identified with the help of stopwatch, or in the stopwatch you fix a time of 1 minute, and in the 1 minute what is the volume will come, let identify that one. For the 60 cc can be taken within 10 seconds or 30 seconds or 20 seconds, that can be measured here. So this is the procedure for measuring the liquid of liquid which is coming out from the chamber to this measuring cylinder, so that we can identify here. Now from this measurement, actually the viscosity, one equation was identified from this experimental setup, that the kinematic viscosity, they identified this kinematic viscosity equal to A into T and minus V by T. This is the equation they got. Now A is here actually a constant value, that is 0.24, and B also having a constant value of 190. Okay, and T is the, as I told, the time period. So as per the equation, we can only go for the time period. That means this 60 cc is filled with respect to at what time. Okay, and here the kinematic viscosity is told, this is the, here the viscosity is given coefficient viscosity, means that is, this is mu, and here it is given kinematic viscosity. So we can convert this kinematic viscosity, which is known as viscosity by density. So if you want to identify, this is mu, so we can identify here mu equal to nu into rho. If you want to write in terms of this, also you can write it. Okay, so this is all about the viscometer, like how to identify the viscosity by this orifice type viscometer. As I told, this is one example of this orifice type viscometer, which is known as Seybold viscometer, and this units will be in the Stokes, and here the viscosity, if you want to measure, you can get Pascal. So this is all about the theory. If you are having any doubt in this, the thank you all.